Here's a question that might keep you up at night. What decides the strength of gravity or the speed of light or the mass of an electron? Turns out it's a surprisingly deep question and one that has puzzled scientists for decades. I'm the host and you're watching this channel. This idea basically says that the values of the constants are limited to those that allow for the existence of life. Another idea is that the constants have a deeper underlying explanation. This idea is based on the observation that the universe is expanding. This idea is based on the observation that empty space, or a vacuum, is really just a seething mass of virtual particles that pop in and out of existence. Some of them are too speculative to discuss here, while others are simply variations on the ones we've already covered. But the main point is that none of these ideas are particularly satisfying. And if you enjoyed this video, be sure to subscribe and follow for more updates. Thanks for watching. Scientists still don't know why the constants have the values that they do. These particles are called virtual because they don't obey the usual relationship between mass, energy, and momentum. The anthropic principle is the most popular idea, but it's highly controversial. Other ideas exist, but they're either too speculative or they don't offer a complete explanation. This question has kept scientists awake at night for decades, and it's less likely to continue puzzling them for many more years to come. But that's the nature of science. There are some questions that we may never be able to answer, but the journey to find those answers is what makes science so exciting. This relationship is called the equivalence principle, and it's embodied in the famous equation E equals mc squared, where E is energy, m is mass, and c is the speed of light. Virtual particles don't obey this principle because they don't have a rest frame, which means that their mass isn't defined. But virtual particles still have a momentum, which is related to their wavelength. And it turns out that the wavelength of virtual particles in a vacuum is always changing due to random quantum fluctuations. If the universe started out in a state of high energy, then there would have been a lot of virtual particles present. And if those particles had a large enough momentum, then they could have caused the fluctuations that ultimately gave rise to the constants. While this idea is very speculative, it's appealing because it offers a potential explanation for the origin of the constants. As the universe expands, the wavelengths of light get stretched, which causes distant galaxies to appear to be moving away from us faster, the farther away they are. This discovery led to the development of the Big Bang model of cosmology, which holds that the universe began from an extremely hot and dense state around 13.8 billion years ago. According to the Big Bang model, the universe has been expanding ever since. But the strange thing is that the rate of expansion gets faster, which suggests that there's some sort of repulsive force pushing everything apart. This force has been dubbed dark energy. If dark energy exists, then it's possible that the apparent constant that we call the gravitational constant is actually a function of the scale of the universe. That means it could change as the universe expands. However, experiments to date haven't found any evidence for this. And there are other theoretical problems with the idea. So while it's an intriguing possibility, it seems unlikely to pan out. This idea is often referred to as the hypothesis of a unified theory because it's just based on the notion that all of the fundamental forces of nature can be explained as different aspects of a single force. One of the holy grails of modern physics is to find a theory of everything that can unify gravity with the three other fundamental forces: electromagnetism, the strong nuclear force, and the weak nuclear force. Physicists believe that if they can find such a theory, then the constants would no longer be arbitrary. They would instead be determined by the properties of the underlying unified force. Unfortunately, we currently don't have a theory of everything, and there are huge obstacles in the way of finding one. So this idea remains speculative for now. In other words, the universe must be suitable for life in order for life to evolve. Sounds reasonable, right? Well, it's highly controversial. For one thing, it implies that we are the center of the universe, which goes against the Copernican principle that holds that Earth isn't in any special location. To be fair, the anthropic principle does come in varying degrees. The weak version simply notes that the conditions required for life must occur somewhere in the universe, since otherwise life couldn't evolve. But the strong version, which is sometimes known as the ultimate reality, makes a much more radical claim. It says that the values of the constants are set by the requirements of life. In other words, the universe fine-tunes itself to support life. Proponents of this idea argue that this is the only way to explain why the constants have the values that they do. Without this tuning, life as we know it could not exist. But critics counter that the anthropic principle merely pushes the question back a step. It doesn't really answer the question of why the constants have the values that they do. It simply asserts that they must have those values in order for us to be here. Join me today as we try to answer one of the biggest questions in all of science: what decides the constants? The properties of elementary particles, like their masses and charges, and the fundamental forces of nature such as gravity and electromagnetism, are called the constants of nature because they do and change over time, or at least within the time frame that we can observe. But just because these constants seem unchanging doesn't mean that they have to be that way. Take the strength of gravity, for instance. If the constant that determines its strength were even slightly different, the sun wouldn't be able to fuse hydrogen into helium, stars wouldn't form, and life as we know it would not exist. And that's just for starters. All of the physical laws we take for granted, from the orbits of planets to the behavior of subatomic particles, assume that the constants have the particular values that they do. So it's natural to wonder why they are what they are rather than some other value. For example, if you took the gravitational constant and made it even slightly larger, Earth would be ripped apart by tidal forces. If you tweaked another constant, the vacuum expectation value of the Higgs field, space itself would be unstable and collapse. And if you changed yet another constant, nuclear fusion in stars would cease to exist. We depend on these constants having the exact values that they do. But what decides those values? Are they just arbitrary and unanswerable? Or is there some deeper underlying order to them? It's a question that has kept scientists awake at night for decades. The most popular idea about how the constants get their values is called the anthropic principle. But the anthropic principle isn't the only idea that's been proposed. Another idea is that the constants aren't really constants, but are in fact variables that change over time. Another idea is that the constants are determined by quantum fluctuations in a pre-Big Bang state of the universe. There are many other ideas that have been proposed over the years. In conclusion, the question of what decides the constants of nature is one of the deepest and most challenging in all of science. So what do you think? Do you have any insight into this issue? Share your thoughts in the comments section below.